So in this video, we will solve a problem 4 related to thin cylinders. And this problem is mainly related to the efficiency, the joint efficiency. Just previous video, we derived the joint efficiency. One is circumferential joint, one is longitudinal joint, right? That is the efficiency of the longitudinal joint and efficiency of the circumferential joint. We derived the equation, okay? That is PD by 2T into sigma C. And how about this one? PD by 4T into sigma L. This we derived two equation. Now apply this to the formulas in this problem here. Okay. So first we will read the problem here. A water pipe with 500 mm diameter, that is 500 mm diameter is there, supplies water at 51 meter head. Whatever the head is there, it is 51 meter head here. Okay. So first we will go the diameter of the first data. We will write the diameter, that is D equal to 500 mm. Just convert, because meter we'll convert all in units in meters. Okay, 500 into 500 mm into 10 raised to minus 3, that is 0.500 mm, right? Just write first 500 mm, later we'll convert. And head how much is supplying here? That is 51 meter head. Okay, taking allowable stress for the pipe, material is 30 MPa. What do you mean by the allowable stress here? That is sigma allowable is given 30 MPa, 30 Newton per mm square, right? So which one? Because we have two types of the stresses developed in the thin cylinder. One is sigma C, one is sigma L. That is circumferential stress developed and longitudinal stress developed. Out of these two, which one is the maximum in the cylinder here? As we discussed in one of the problem before, that is circumferential stress. Circumferential stress is maximum compared to longitudinal stress. That is only he is given maximum allowable stress. So can I write this one equal to sigma C, right? Circumferential stress. Longitudinal stress is half of the circumferential stress. Okay, so this is double. So that's why the maximum stress is circumferential stress only inside the cylinder. You remember this one. So is given sigma C. Next, and efficiency of the circumferential rivet. So efficiency of the circumferential rivet is how much? 80%. 80% means that will be equal to 0.8, right? 0.8. Determine the thickness of the pipe. You have to determine thickness equal to how much. Okay, and specific weight of the water is given. The specific weight is, that is 9.881 kilonewton per meter cube. Just convert this one Newton per meter cube. Okay, just 9.81 into 10 raised to 3 Newton per meter cube. I just converted here. Here also meter is there. And now this will be 500 into 10 raised to minus 3, right? Meter. That is 0.5 meter, right? 0.5 meter it will come. Directly you can write it, this one be equal to 0.5 meter. This is the data he is given here. Now we have to find out, he is given the diameter, he is given the height of the water, you have to pump it, and allowable stress of the cylinder, the thin cylinder, and the efficiency, circumferential efficiency is given, and specific weight of the water is given. You have to find out the thickness of the cylinder, wall thickness of the cylinder. So how you will proceed? How will start the problem here? So he is given the circumferential efficiency, right? We derived the equation for the circumferential efficiency in the previous video. So what is the circumferential efficiency here? Circumferential efficiency equal to PD by 4T, right? PD by 4T into the longitudinal stress. This is the formula we derived here. Now apply this one. He is given the circumferential efficiency 0.8, and pressure of the fluid is not given. Diameter we know, that is, if you want you can just write it this one with capital letter, and thickness we don't know, and also the circumferential, the longitudinal stress we don't know. we will go one by one how to calculate the P here. Okay, so to calculate P, how we'll go, he is given the specific weight of the water and height of the water, right? So P equal to specific weight into height. This is one formula. Specific weight of the water into height. How much is the specific weight? 9.81 into 10 raised to 3 Newton per meter cube, right? So 9.81 into 10 raised to 3 Newton per meter cube into height of the height, how much is it is there? You have to supply 51 meter. All are in meter. Okay. Now calculate the pressure from this one. If you simplify and calculate here, that is 0.5 into 10 raised to 6. 0.5 into 10 raised to 6 Newton per meter square. This is P. Pressure we found. Better we'll put net because diameter. Okay, no problem. Next, P is finished. Efficiency we know. Now calculate the longitudinal stress here. That is sigma L. What is the formula? Sigma L equal to PD by 40, right? PD by 40. This is the general formula. This will be equal to sigma L equal to half of sigma C, right? Apply this one. That is the half of sigma C. That is sigma C by 2. Apply this one. Okay. Now substitute all these here in this equation. We will come to know. Just we will go there. First, this is 0.8 equal to P, already it is there. Better we'll convert this also in terms of meter and keep it this one in terms of mm. Put it this one in terms of mm, and this also you convert in terms of mm. That is 0.5 Newton per mm, right? Newton per mm square. P equal to this 6, it will go here Newton per mm square. Now all will put it in mm here, this one. Okay. So 0.8 into P is 0.5 Newton per mm square. That will be equal to 0.5 Newton per mm square. Diameter also in mm, diameter also in millimeter, into 500 divided by 4. We don't know the thickness, into this is sigma C by 2. This is sigma C by 2 here. Again, sir, we know that sigma C here, right? Sigma C is what is the sigma C? Allowable maximum allowable stress is given. That is nothing but sigma C. Substitute. That is 0.8 equal to 0.5 into 500 divided by 4 into T into maximum allowable stress is 30. 30 divided by 2. So into T. This is T. So only T is unknown here. Simplify and calculate. From this one, the thickness of the cylinder we will get after simplification, that is 5.2 millimeter. 5.2 millimeter. Okay. This is how, if the efficiency and allowable stress is given, you have to calculate the thickness here. Okay. Only the thing is, you have to apply two formulas in the for the problem here. The one is the longitudinal efficiency, one is circumferential stress efficiency. That we derived before, that I wanted to apply here. So this is how the calculation is.